Alright, in a previous video we talked about the on-off cycle of the cutting head and the principles of how the cutting head works and how the abrasive is drawn into it. If you haven't watched it, go watch it because it's critical as a prelude to where we are now and how we can try and pierce the stone without destroying it. Certainly, the goal is to make sure that when the water comes into contact with the stone, it's mixed with abrasive, and that we've done everything that we possibly can to reduce the chance of our crater being created. We do that in several ways as far as the crater is concerned. One, we've got to do a low pressure pierce. Okay? If you try to just turn the cutting head on with full abrasive, it's just going to come down and it's just going to smash it out. With or without abrasive, it's probably going to pop it. Try it. Go to your cutting head, put some stone there, turn the pressure up to 60,000, turn the abrasive and the water on at the same time, and you'll probably blow it out every single time. Okay? So clearly, high pressure is not a good thing to do, and maximum power is not a good thing to do to actually hit your stone when you're first doing a pierce. You want to go to low pressure piercing. Nearly all of Waterjet systems have optional low pressure piercing. When you program the software, or when you actually draw the part, you can just select the post processor that will automatically go and send a signal to the pump and say, hey, go to low pressure. And if you have the variable speed mini hopper, what it'll do is it'll say, hey, pump's going to low pressure. If you remember, we talked about the venturi and the air, the vacuum being generated and the abrasive being drawn in. Well, as you turn the pressure down, so less vacuum is generated. As less vacuum is generated, there's less capacity to take abrasive away. If you leave the full amount of abrasive coming down, but you reduce the pressure at the pump, you're going to get a blockage in your cutting head, and all the things you saw in the last video will happen. So we've got to match the abrasive flow with the pressure, so less pressure, less water, less vacuum, less abrasive. The Waterjet system with the variable speed mini hopper will automatically do that. If you don't have one, there's ways that you can go and probably adjust things manually and just pause while you make that adjustment. But generally all our systems go out with abrasive, the variable speed systems. So it will get a message. You can go and set the abrasive on the Waterjet mini hopper. Just going to grab me one there. On the Waterjet mini hopper, there will typically be two settings. So you can come in the back here and there will be a circuit board and you can make an adjustment. Actually, you don't even have to take it apart. You can do it from the outside. And the intention is that you can go and say, okay, this is what I'm cutting at full pressure, and you can regulate that and measure it. That's another whole topic. And then this is what I want to be when I'm at low pressure. We don't know what you're going to set your low pressure at. We don't know if you're going to do it at 8 or 10 or 12, 15 or 20,000 psi. But you've got to have a matching abrasive flow for that. So set the low pressure to whatever you want it to be, the high pressure to your optimum maximum power, and make sure that the signal's going to your cutting head and to the mini hopper and your pressure is dropping at the pump. So what we'll do is we'll first go to low pressure, get a low pressure signal, drop the pressure at the pump, and reduce the abrasive. Okay, so that's the pump and the abrasive will be adjusted. The second thing you want to do is you want to make sure that you never do a stationary pierce. If you switch the stream on in one position, we're going to land up with this kind of thing happening where everything that comes down has to go back up, and you will get an incredible amount of pressure, as we talked about before, and the thing will pop off. If, however, we could create a path where it came up like this, so everything that came down was able to do its work and then had an escape route because the next bit was coming down, you'll find you can increase, you can pierce up to 10 times faster, not 10%, 10 times faster by doing this. It's very substantial, especially in harder materials. Stone is not a hard material, but you'll still be faster, not 10 times, but much faster. How do you do this? Well, you could either have a program which just literally goes round and round and round and round, and all we'll do is you'll see that as you pierce and as you're going round, it'll have a tail that'll spin around like this, because the water's going down, doing its digging, and coming up, and it's sort of kicking around. That's one way to do it. Another way is just to simply do a line. So if I was going to try and cut this, I could pierce here and just go along, and by the time I get here, I'll make sure that the material, that the stream had got all the way through the stone, and then I could ramp the pressure up, and then I could cut it at full speed with full power. So first thing you want to do is you want to make sure that you go to low pressure at the pump and you reduce your abrasive. Second thing is you must be moving. Okay. Now, there are even ways on the Waterjet system where we can make sure we are moving before you switch it on. It requires certain algorithms, and you'd need to contact us, but it is possible to do that. Certainly in aerospace it's a big thing, where we're cutting carbon composites or aircraft wings, where the value is 1,000 times the value of a slab of granite, and if we got delamination, because of the same kind of things, it would cost hundreds of thousands of dollars per part. We obviously can't afford to have that. So there are definitely ways of doing and getting low pressure piercing. I would suggest you try to figure out and focus on low pressure piercing and get a stone. And I used to, in the end, try to get a piece of glass or stone and see if I could actually pierce holes 1 inch apart from each other and see how many I could set up to know that I had it set correctly. Because if I could do that, I know that I already am in quite good shape as far as understanding what's going on. We still have the challenge, if you remember, that the off cycle, ideally you bleed the abrasive, you let the abrasive actually get flushed out. Now you have a cutting head with no abrasive in it. When you switch it on, you've got the water coming down. It's going to take a second or two for the abrasive to get there. You're going to have water coming out first. You're going to end up damaging your part. Well, depending on the stone, if you had low enough pressure, you might find the low pressure doesn't damage the stone. However, when you're cutting stone, you might just have to say, hey, here's a really complex part. I'm going to have to do a pierce on the line because I want both sides of the material. I don't want to have a lead-in where I damage part of the material so that I have a safe, no chance of damaging the good material. And you might have to say, I will not purge the line of abrasive. In other words, you go to an off cycle, and typically the post-processors that we have will automatically do this, and they have all the timing in already, so you can always call and ask and check what their timing is, understand it. But you want your abrasive and your water to basically go off at the same time. That means the abrasive will run down to the bottom because it didn't all get flushed out. It does mean you run a higher risk of damaging the orifice from the bottom. Shouldn't be too much of an issue with the Waterjet cutting head because we actually have a smaller path because we know this is a big deal, so the abrasive can't get up and it has to come through this wear insert. So the chance of damaging your orifice from the underside is greatly reduced. And we don't have to have a vacuum assist or something like that. So you switch them both at the same time. When you're going to start cutting, you do the unthinkable. You turn the abrasive on first, and a split second later, maybe a quarter of a second later, you turn the water on. So we've got some abrasive sitting here already on our, here's the water coming down. We have some abrasive sitting here. You turn first your abrasive on, it starts finding its way down. But remember, there's no vacuum yet because you haven't turned the water on. So it's heading down this tube, but it's just dropping by gravity. You turn your water on second, it creates the vacuum, it draws this through as a slug, goes straight in, and you land up with water and abrasive, and it immediately starts doing the erosion. In the process, it starts sucking in your abrasive. The danger of doing this is you are running a much higher risk of clogs and blockages, and you could land up damaging your abrasive, but it's something you should be pricing in if you're going to do a lot of low pressure piercing. Danger. Water and abrasive do not mix when it's supposed to be dry. Your abrasive must be dry. If you have abrasive sitting here in this process, and your needle and seat, there's a needle and there's a seat that this fits in, that's switching on and off your water. If this is leaking, okay, and you will know it's leaking because either water will start to come up here by capillary action up the tube, or you might find when you switch the head off, when you're not cutting, but the pump's running, that drops of water are coming out the bottom here. That means you've got a leaking needle and seat. If that's leaking and this water gets in here, this will get moist. When you try to do this, the abrasive will come here, this will clog, and bam, you'll have an instant clog. And then you may land up eventually building up, coming out with a rush, and then you'll end up clogging it. Now, this potentially is sounding like a really big issue. Actually, it is a big issue if you don't sort it out. There are hundreds of people who cut every day, all day, every kind of stone. Glass, if you think stone is tough, try glass. We sell machines to glass companies, and they only cut glass, and they cut holes every single day, and thousands of them all the time. You can get this right. You need to understand it. You've got to understand what the principles of on-off are. A lot of this is already built into the programming, but you need to understand the concepts of how to make sure that you can pierce your stone. You need to try it, test it, try your different stones. Every stone is different. Some stones, it's completely irrelevant what you do because there's a fracture plane in the stone. So when you pierce, it doesn't matter whether you did it right or wrong. It's just going to pop out in any case. So depending on the structural integrity of the stone that you're working with will depend on what happens here. They are all overcomable to the largest extent. So hopefully this has helped a little bit. Just to end off quickly, one of the questions I always get asked is how much must I charge for my Waterjet cutting? Well, obviously you need to figure out what your costs are depending on your geographic location. That's going to make a difference. How much competition you have, what other people are doing out there, that's all a given. But generally, artwork and stonework, because of a lot of this, fetch a higher dollar per hour rate. I would never ever give anyone my rate per hour. I'd rather give them the cost per piece of what I'm trying to achieve. But generally, steel cutting, safe cutting is normally going at 140 to 160 an hour. Artwork like this, there are people who say they won't even touch it for less than $250 an hour. I can't tell you you're going to get that amount of money. I don't know how you're doing your CAD and your CAM. I don't know how you're doing your programming. I don't know what your parameters are. I don't know what pump you have. I don't know what speed you're running at. I don't know what quality abrasive you have. I don't know how are your controls that you are implementing. I don't know how much time you're going to spend with issues of piercing. But there are some people who won't even touch it for under $350, and they are very successful. But they might be producing twice what you might for the first couple of months while you figure it out. So it's more a case of getting familiar and understanding exactly what you're looking at and being able to make that all come together. So hopefully this gives you some idea about stone cutting. If you have any ideas, please always contact us. It takes minutes to answer a question, and I'd be happy anytime to do that. Thanks.